It's the fourth week of pandemic learning, and this week's lesson focuses on angle relationships. Included in your package is a geometry reference page. Now, quite a bit of it you might already remember from elementary school. Things like types of angles that you can have. An angle can be acute if it's less than 90 degrees, a right angle if it is exactly 90 degrees, a straight angle if it's exactly 180 degrees, obtuse if it's between 90 and 180 degrees, or if it's even larger than that, greater than 180 degrees, we call it a reflex angle. You might also recall that there are different types of triangles based on what kinds of angles are within the triangle. An acute triangle has all angles being less than 90 degrees. A right triangle has one 90-degree angle and two acute angles in it. And an obtuse triangle has one angle that's greater than 90 but less than 180 degrees, and it also has two acute angles in it. Triangles can also be named based on their side lengths. So if all three sides are exactly equal in length, then it's an equilateral triangle. An isosceles triangle has two sides that are equal, and a scalene triangle has no sides that are equal to each other. The main focus of this lesson is on angle relationships. Some of these might be familiar to you, and some of them will definitely be new. Complementary angles, for example, are angles that add up to 90 degrees. In my example, I have broken down this right angle into two acute angles and have indicated that angle A plus angle B equals 90 degrees. Now, what might be new for you is that you're going to be required to provide the correct acronym to go along with that. That's our way of justifying the value that we're coming up with. Similarly, supplementary angles are angles that add up to 180 degrees. So I've broken down this straight angle. Notice the straight line right here. This straight angle has been broken down into angles C and D, and they add up to 180 degrees. Again, you'll need to provide the justification for that, and we use ASTT, standing for Supplementary Angle Theorem. Similarly, complementary angles were Complementary Angle Theorem for the acronym. All of the angles inside of a triangle add up to 180 degrees, and angle sum triangle theorem is the name of that relationship. You will often see it abbreviated to AST and sometimes ASTT, depending on the text. So the relationship is that angle A plus angle B plus angle C equals 180 degrees, and our justification is AST. Isosceles triangle theorem has the acronym ITT for its justification. The isosceles triangle theorem states that if two side lengths are equal in a triangle, then the two base angles must also be equal to one another. Unlike the previous three relationships, rather than having the two angles adding up to a specific value like 90 degrees or 180 degrees, these two values are actually equal to one another. Angle A is equal to angle B. Opposite angle theorem is abbreviated to OAT. And it states that angles that are vertically opposite to one another are actually equal to each other. So C and D are opposite to each other, and A and B are opposite to each other. So those pairs of angles are equal, and our justification is opposite angle theorem, OAT. So anytime you have two lines that are crossing like that, look for that relationship. See if you can answer a question using it. Finally, on this page, we cover the acronym EAT, EAT. It stands for Exterior Angle Theorem, and this theorem states that An angle that is on the outside of a triangle, so this is the exterior angle, is equal to the sum of the two angles inside of the triangle that are not directly beside the angle, the exterior angle, not the one adjacent to it, but it's equal to the sum of the other two angles within that triangle. These are the interior opposite angles to that one. Well, how do we put these relationships into practice? I've given us some examples here. We're being asked to find the missing angle measures and to give reasons for our answers. In question 1, I've got an isosceles triangle, and I know that that's so because these two symbols are indicating those two side lengths are equal to one another. So I can automatically say that angle A is equal to 70 degrees because of the isosceles triangle theorem. Note the acronym must be provided with the value. To solve for angle B, I'm using angle sum triangle theorem, shortened to AST. I know all three of those angles are going to add up to 180, and now that I've already established that angle A is 70 degrees, then I write an equation. So angle B plus 70 degrees plus, this is the value of A, also 70 degrees, is equal to 180 degrees. Simplify the numbers on the left side, add them together to get 140, and now we want to isolate B. So we will subtract 140 degrees from the left side to get B by itself, and we will also subtract 140 degrees from the right side to get its value, which is 40 degrees. So you need to set up the equation, provide the justification with the acronym, and then simplify what you can on either side of the equation, and finally algebraically manipulate it to get the value of B. Question 2 also involves an isosceles triangle. Again, note the symbols on the sides there. We're only given one angle measure. I know that this top angle is 150 degrees again. And what's different from the previous question is we're not actually given one of the base angles. That is, question 1 was pretty easy to start because we were given 70 degrees as one of the base angles. We could come up with the other one. Well, I can still establish that I know this angle and this angle are equal to each other. Note the style that I used to name those angles. Angles are identified sometimes using 3 letters. I purposely used this style because I wanted you to be familiar with it. It's possible that you already are, but it might also be new information. So I could refer to this angle right here as angle B, or I could use this 3-letter style. Notice that the B is in the middle. The one that's most of interest is going to be the letter in the middle. Similarly, I could have called this angle C, but if I use the 3-letter style, then the C is in the middle. It doesn't really matter what order the other letters go in. I could have also called this angle BCA. BCA. Note that the C is still in the middle. It's important to establish right off the bat that these two base angles are equal to one another because of ITT. Because I need to use that information when I set up my equation in the next line. So I know that 2 times the value of, and I could have used either one of these because they are equal in value. So 2 times the value of angle ABC plus 150 degrees equals 180 degrees because all the angles in the triangle add up to 180, AST. I subtracted 150 from this side of the equation. I did the same thing from this side of the equation, and it gave me a 30 in that position. So now 2 times the value of angle ABC is equal to 30 degrees. If I divide both sides by 2, then I get the value of angle ABC, which is 15 degrees. So I know this angle right here is 15 degrees, and it is already implied that this angle, this other base angle, is also 15 degrees because that was established right at the beginning of the answer. In question 3, I'm given the value of the exterior angle outside of a triangle. I also know one of the opposite interior angles, and because I have the value of those two, I can solve for angle A. Angle A plus 25 degrees is equal to the same value as the exterior angle, 100 degrees. Subtract 25 from the left side, do the same thing from the right, and we can get the value of A, which is 75 degrees. Now that I know that A is 75 degrees and this angle is 25 degrees at the top, I could find angle B using AST. That is, the sum of the angles is equal to 180 degrees inside a triangle. Or I can use supplementary angle theorem. Angle B and the 100-degree angle are along a straight line. So I know that these two add up to 180 degrees. So the math is a little bit shorter using that relationship. It's not wrong to use AST, but SAT was just a little bit shorter for a solution. Both would give us a value of 80 degrees for angle B. In question 4, I have complementary angles. There's a square inside this diagram, which is suggesting that it's a 90-degree angle. So these two values must add up to 90 degrees. X plus 62 equals 90 because of complementary angle theorem, CAT. Subtract 62 from both sides and it gives you the value of the unknown angle, which is 28 degrees. In example 5, I have two lines crossing each other. That means I can use the opposite angle theorem relationship. Might be a little hard to read. This angle is 12 degrees, so I know the angle opposite to it, angle A, is also 12 degrees. That's the first thing I establish. Once I have that angle, there is a variety of ways that you can continue from here. I focused on the straight line relationship with the 12 degrees and the B. You could also focus on this straight line with the A and the B. Either way, we're working with angles that are along a straight line, and therefore they are supplementary angles. So B plus 12 degrees equals 180 degrees. Subtracting 12 from both sides gives a B value of 168. Once you know the value of B, the angle opposite to it is angle C, so it must also be 168 degrees. Note again, I'm consistently providing the justification using the acronyms. Before we can answer the next question that was on that last page, we need to explore some other angle relationships that I haven't talked about yet. The following relationships are born out of what we call parallel line theorem, PLT. When you have two parallel lines and a line that cuts through them, which we call the transversal, then there are three key angle relationships that can arise depending on the shape that you see. The angles could be alternate angles. And in grade 9, we use the acronym PLT-Z because we want you to identify the shape. Notice that I've got a Z indicated here and a backwards Z here, or a dyslexic Z if you like. In both cases, angle A and angle B are equal to each other, whether you find what you're considering the regular or normal Z or the one that's flipped around. The reason that we're going to use in grade 9 is PLT-Z. In grade 10, we ask you to learn the angle name, which is that they are alternate angles. So you're going to look for a forward or reverse Z shape if you're using that acronym PLT-Z. Interior angles involve the acronym PLTC, because C is the letter that we're looking for. Now, just as the actual name implies, interior angles are on the inside of the parallel lines, and they're always on the same side of the transversal. So they're either both to the right of that line that cuts through the parallel lines, or they're both to the left of the line that cuts through those parallel lines. PLTC is the acronym because we're looking for either a forward C shape or a reverse C shape. And what's special about them is that those interior angles are going to always add up to 180 degrees. So when you use that relationship, one interior angle plus the other interior angle will add up to 180. The third relationship that's born out of parallel line theorem involves what we call corresponding angles. The letter that you need to look for is an F shape, and again, that can be a regular F, as I've depicted here. It could be a reverse F. It could be an upside down F. Oops. Or it could be an upside down and reversed F. In every case, angle A equals angle B. In every single one of those diagrams. The word corresponding actually means in the same relative position. So in these cases, it means the two angles are in the same position relative to the transversal. That means they have to be on the same side of that transversal line. And also, they are in the same position relative to the parallel lines. That is, they are either both above the parallel lines or they are both below the parallel lines. In the sixth question, I began the answer using PLTC. So these are interior angles inside of the parallel lines on the same side of the transversal. And A plus 80 equals 180 degrees. So A works out to 100 degrees. Now angle B, one moment please. Here we are. For angle B, I used the alternate angles relationship. So I saw the Z shape here, which I'm depicting with the highlighter. And alternate angles are equal to each other. So we write B equals 100 degrees, PLTZ. Remember, A was 100 degrees, so B must also be 100 degrees. For angle C, I said that it's also equal to 100 degrees because of PLT-F. And this time I'm showing you where the F shape is. So the A and the C are both below the parallel lines and both on the same side of the transversal. So you could use that PLT-F relationship. I said, or you could use opposite angle theorem. Remember, I had just finished figuring out that angle B was 100 degrees, so directly across from it here, note these lines, is angle C, which means that it's also equal to 100 degrees. Question 7 is a combination question. You'll note I have parallel lines, and within the parallel lines, I have an isosceles triangle. Notice these sides are equal to one another. I'm being asked for the top angle within that isosceles triangle, and also these two angles, B and C. Sometimes it's hard to know, where do I even begin? Well, begin by focusing on the angle that's given, which is 65 degrees, and look for something that you know will be equivalent to that, or something that will help us out. It would be ideal if we actually had some other angles inside of this isosceles triangle. So I've begun by calling these angles by some name. The other letters were A, B, C, so very creatively I made this angle D and this angle E. And I've established right off the bat in my answer that D is equal to E because of Isosceles triangle theorem. I also know that angle D is equal to 65 degrees because of PLT-Z. So there's a Z shape in here. That means angle E is also 65 degrees. And knowing that both of these are 65 is going to enable me to figure out angle A. So angle A plus 2 times 65 degrees. This takes care of both angle D and angle E, both being 65. That's equal to 180 degrees because of angle sum triangle theorem, AST. Well, 2 times 65 is 130. And if I subtract 130 from each side of the equation, I get an A value of 50 degrees. So I know that that top angle in the isosceles triangle is 50 degrees now. So angle A and the 65-degree angle and angle B are all along this straight line. The sum of them would be 180 because of supplementary angle theorem. So that's what I'm going to do next. B plus the value of angle A, which is 50 degrees, plus 65 degrees equals 180 degrees because of SAT. And B plus 115 degrees, so 50 plus 65 is 115 degrees. Here we are again. B plus 115 degrees equals 180 degrees. Subtract 115 from both sides to get B equals 65 degrees. I just need to figure out angle C now. And angle B and angle C are on the inside, in between these parallel lines, and they're on the same side of the transversal. So you have to see that this side length in that isosceles triangle is actually a transversal cutting through the parallel lines. So angle C plus angle B, which is 65 degrees, equals C plus 65 equals 180 degrees because of PLTC. Those are interior angles. And C equals 115 degrees. I hope you'll notice that I'm modeling for you that by the time I get to a final value, or I know the value of an angle, I put a box around it. Is it mandatory? No. But does it help a person who's staring at your answer make sense out of what you've done? Yeah, it does definitely help. It signifies I finished this section, now I'm starting a new section. So it's not a bad practice to get into. We're in the home stretch here. We just have a couple more questions to do. In this last section, instead of being given the angle measure in a diagram, like saying an angle is 70 degrees, for example, we have algebraic expressions representing the angles. This question is asking us to solve for angle DEH, which is this angle right in here. DEH. Well, I'd first need to solve for x to enable me to figure out, well, how big is this angle here? And then I'll know how big this angle is because I see that these are opposite angles to one another. That's one way of approaching it. Well, how do we solve for x? I chose by focusing on the PLT-F relationship. So this angle and this angle, angle DEB, are equal to each other because of PLT-F. Please note the upside down, reversed F shape involving those two. Then I said to myself, well, angle DEB and the angle that's identified with a 2x here Those two would add up to 180 degrees because they're along a straight line. So that's the SAT relationship. So remember, angle DEB is equal to 3x minus 20 plus 2x equals 180. So 5x minus 20 equals 180. 5x equals, now add 20 to both sides to get 200 here. The value of x is 40 degrees. Finally, I'm able to use my opposite angle theorem relationship. So angle DEH is opposite to the angle that had the 2x there. I know they're equal to one another, therefore. So angle DEH equals 2 times 40, or 80 degrees. Just one question to go. We're using the supplementary angle relationship again in this question because all three of these angles are part of this straight angle. So I know that they all add up to 180 degrees. We're asked to find the value of x and then state the value of each of these individual angles. Angle ABD is this one with an x. Angle DBE is the one that has 10x minus 30 identified as its size. And angle CBE is the one with the 3x. So let's use supplementary angle theorem first to figure out what the value of x is. So once again, the sum of all three of these expressions equals 180. So I've added x plus 10x minus 30 plus 3x equals 180. Always simplify like terms on any side of an equal sign. X plus 10x is 11x. 11x plus 3x is 14x. And I still have to subtract 30 on that side, until I add 30 to both sides to get rid of the minus 30 or subtract 30. It gives me 210 on the right, and dividing both sides by 14 gives me an x value of 15. Once you know that x value of 15, you can substitute it into each one of the three expressions because this question asked us for the angle measures. So angle ABD was equal to the value of x, so I just write angle ABD equals 15. The expression 10x minus 30 gives the size of angle DBE, and subbing in 15 in place of x and working out the math gives me an angle measure of 120 degrees. That makes sense. That's a very big angle. That's an obtuse angle. And finally, angle CBE is equal to 3 times the value of x, which works out to 45 degrees. The end of your 4th lesson. Good luck with the practice questions. I'll talk to you next time.